Hey, Qiming.
Hey, Lance.
Nice to see you here.
Good to see you.
Yes. Yeah, so today's topic, the past, present, and future of NKG mice.
Yeah, this is my favorite topic.
Okay, I know it's your favorite topic.
Yeah.
Yeah, you've been with Cyagen for how long? 6 months already?
Yeah, 6 months into the job.
Yeah. So you might want to introduce yourself a little bit first.
Yeah, sure. Just hello to the audience. My name is Qiming Wang. I've been with Cyagen for 6 months. My major role at Cyagen is to drive product innovation and also to develop the go-to-market strategy for the mouse models we currently developing. And prior to that, I was at the Jackson Laboratory, or JAX, for 10 years.
Wow.
5 years in Bar Harbor, their main campus, and 5 years in...
So you did your PhD there?
Yeah, I also did my PhD there, and 5 years in China. That was my history of working with mice.
Wow.
Yeah.
So you consider yourself immunologist?
Yeah. I was an immunologist by training. I did my training in type 1 diabetes using NOD mice, as we're going to talk about. That's part of the genetic background of the NKG mice. And yeah, I did a lot of translational work in the type 1 diabetes mouse model.
So you studied with whom?
Yeah, my PI at JAX was David Surratt, who is a very renowned immunologist. Yeah, he developed quite a few humanized NOD mice for translational studies. Okay.
Well, so you started from the root of it.
Yeah. You can say that because the NKG or NSG NOG is really a manifestation of the evolvement of mouse model.
Yes.
And the way I mean the evolvement is that it really starts from the inbred strain of the NOD and a spontaneous mutation called SCID, which at that time people don't know what gene which it counts for, but name is SCID. That's given after its phenotype, which stands for severe combined immunodeficiency, SCID.
Yes.
And then people found that was due to a mutation in the PRKDC. So. And for the G, which stands for the L2 receptor gamma, that's when the people can make mouse ES cells and do genetic manipulation on the mouse ES cell. And then when the things all things put together, that makes the NXG or NSG, NOG, and our NKG mice. Okay,
so let's talk about the past first.
Yeah, sure.
Yeah, so it started with NOD.
Yeah.
Do you want to build up the storyline, how it got started from NOD and all the way up to this moment?
Yeah, sure. So NOD itself is a kind of interesting story because the mice originally started from the ICR, which is an outbred, and then people selecting for the mice that has the high fasting glucose phenotype, but also non-obese. So that's why given the name NOD, which stands for non-obese diabetes mice. So that's how it got its name. And this was developed in a company in Japan called Shionogi. And at that time, one of their researchers trying to get a research position in the U.S. So he kind of smuggled
smuggled.
Yeah, so
from Japan to the U.S.
From Japan to the U.S.
Oh my goodness.
Trying to study on this mice, and
this would be considered a crime nowadays.
Yeah, but at that time it was quite wild. I should just say that. So he landed the plane with 2 pair of breeders in his backpack, I guess, and then started doing the research work at the Joslin Diabetes Research Center in Boston, but also sent the mice to the Jackson Laboratory. And at that time, the researcher and who has been in the field for the past, say, almost half century, his name is Ed Leiter, which is my PI, David Surratt's mentor. So at the Jackson Lab, they had studied this mice for almost 50, 60 years now.
Okay, so that was in probably early 80s?
Yeah.
Okay, wow. So the NOD was kind of discovered during the screening. Correct me if I'm wrong. So originally they were trying to, screen for a type 2 diabetes, but ended up finding some model that resembles the type 1 diabetes.
Yeah, that's correct, because the NOD mice has a lot of characteristics of the type 1 diabetes patients, because it has an autoimmune manifestation, which means that the B cells make autoantibodies, like anti-insulin antibodies, and the T cells also attack its own pancreatic beta cell.
Yeah, yeah. So the NOD is, you can consider it kind of a happy accident.
Yeah. That also provides a lot of insights into sort of like the mechanics study and the therapeutic development in the type 1 diabetes population.
Okay.